Thank you for coming out to see our Space in the Community event tonight. We're really excited about that. If I didn't have a chance to shake your hand or meet you out there, my name is Matt Buckler, and I'm the principal of Erie High School. And I want to share a quick story before I do some thanks and introductions. I was thinking about the first major world events that I remembered as a kid, because I was a history teacher, and there was a connection with this because I remember it was like about 1972. I was about 5 years old, and I was thinking, well, there's three things I remember. One was Evel Knievel. And parents are laughing and kids are not. They're going, who's Evel Knievel? Google it tonight. He was very cool, and he was a world hero to me. On a more personal connection, my uncle went to Vietnam when he was 19 and came back right around that year. So that was a poignant moment for our family. But the third and biggest thing was the Apollo missions. I mean, as a child, I remember seeing that on a little black and white television. It's just tremendous. And now here we are in 2016, and we're talking about going to Mars. So it's just very exciting. So that's my little story for you. I want to thank some folks on behalf of all of our schools. First and foremost, Mrs. Christina Stem. Christina is the STEM coordinator at Erie Elementary School, and she's done a lot of work, and she put together the grant that allowed us to bring Dr. Leroy Chao and the rest of our distinguished guests. So thank you, Christina. I also want to thank Mrs. Lisa Hoxie and Mr. Lee Berg. They are representing the St. Vrain Education Foundation, and they've been very generous in their support of our school, so we thank them very much. Very special thanks to our sponsors, Amgen, Northrop Grumman, and Fisher Construction, for supporting science education in our Erie schools. And I want to thank the exhibitors as well. Most of those folks out there are friends, family members in the Erie community. We have a lot of engineers and a lot of people in aerospace out here in Erie. And then the last thanks goes to Miss Kelsey Johnson, our engineering teacher here at Erie High. She has breathed fire and enthusiasm and energy into our program here. And I just want to thank her and her students for their exhibits out there. We have several distinguished guests here tonight. We have St. Vrain Valley board members and some assistant superintendents. All of our principals in Erie are out here, and we thank them very much for being here. And now, without further ado, I would like you to join me in welcoming Mr. Brian DeBates. Brian is the Senior Director of Education at the Space Foundation, and he administers the development and implementation of STEM education. So, Brian, if you'd come up and join me. Thanks very much, folks. Enjoy the evening.
Thank you very much. Well, I would also like to thank Principal Buckler for putting together this amazing evening at his school. And so if we could all give him a round of applause as well. And I'd like to echo his thanks as well to all of the sponsors, the administration here at the school district, and just for all of you for coming out and supporting STEM education at your school district. And I don't know if you've had a chance to look at all of the student projects out in the foyer yet, but amazing job. I think this school district is sitting very well in regards to the future of STEM education. I'd also like to thank my team that's here this evening. We have Kara Barbarick, Jamie Sunkel, and Elias Mullen, who are education specialists, just absolute rock stars. Makes my job very easy. And we have Lisa Bell, our Education and Discovery Sales Associate, and so she works a lot of the logistics. So thank you to them. Like I said, makes my job very easy and very enjoyable to come to places like this. And I'd also like to thank our panelists. All the way from Boulder, shortest distance to come, but also from Florida and Houston. And so what I'd like to do is introduce the panelists. And what we're going to do tonight is I'm just going to ask them some questions to start a little bit of a dialogue so that they can share their experiences. The whole point of space in the community is to get communities behind STEM education in their districts. And we were joking a little bit earlier, my team and I, that this is probably one district in the country that doesn't need a whole lot of help in that respect. But the attendance tonight does echo how much support there already is. And so our idea is to bring amazing individuals like these four that you have up here, let them share their stories to get you to understand why space is important to your life and why STEM education needs to be supported. So I'm very quickly going to introduce our panelists. We'll just do it alphabetically. And just reading their bios, we could be here for about 2.5 hours. So the hardest job I had tonight was trying to pick out the little bits and pieces of their amazing careers to share a little bit about them with you. So first we have Dr. Leroy Chao. Dr. Chao has traveled to space 3 times aboard the space shuttle and once aboard a Soyuz rocket, where he spent 6.5 months as commander of the International Space Station. Dr. Chao holds appointments at Rice University and the Baylor College of Medicine, as well as being the special advisor human spaceflight for the Space Foundation. He studied chemical engineering at UC Berkeley and received his PhD in philosophy from UC Santa Barbara. We also have Sherry Fike. Sherry is Vice President of Mission Assurance for Ball Aerospace and Technologies Corporation. Specifically, she is responsible for defining and executing mission assurance for all Ball Aerospace programs. She has more than 35 years of experience and has been awarded the 2 highest Ball Aerospace Excellence Awards, the Follett Award and the Gabe Award. She earned a bachelor's degree in computer science from Penn State University. Next is Dr. Lisa Hardaway. Dr. Hardaway is a program manager for Star Trek and other scientific instrument programs at Ball Aerospace and Technologies Corporation. She was the technical manager for both the Hubble Space Telescope's Wide Field Camera 3, as well as the Ralph camera on the New Horizons mission to Pluto, which flew by Pluto this past summer. She is the recipient of numerous awards, including the Women in Aerospace Leadership Award. Dr. Hardaway holds a BS in Aeronautics and Astronautics from MIT, an MS in Mechanical Engineering from Stanford University, and a PhD in Aerospace Engineering Sciences from the University of Colorado in Boulder. And finally, Colonel Joe Kinniger. Colonel Kinniger was first accepted into the United States Air Force Aviation School at Goodfellow Air Force Base in 1949. He was a fighter pilot in Germany until 1953. He later became a test pilot for Project Manhigh, where he piloted a pressurized gondola to an altitude of 96,000 feet. In 1958, he moved to Project Excelsior with the goal of putting a man in space and to test a person's ability to test high-altitude bailouts. In 1960, he piloted his gondola to an altitude of 102,800 feet, that's 19.5 miles. He received the Joe Harmon Trophy for outstanding accomplishments. He was a fighter pilot in Vietnam, where his F-4 Phantom shot down a MiG, and he himself was shot down, and he spent 11 months as a POW. Now he serves as an aviation and aerospace consultant. He most recently used his knowledge in the Red Bull Stratus jump to help break his 50-year-old free fall record. So one more hand for our panelists. Okay, so I will pose a question and I will give each of the panelists a chance to respond, to share their personal experiences. And once we've gone through the questions, we'll have a little time limit, and at the end we will have a question and answer from the audience. So we'll start on the far end. Dr. Hardaway, tell a little bit about your experiences, projects, missions having to do with space, and what highlights of your career would you like to share?
Thank you. So I've been really fortunate to work on two really exciting programs, ones that really have driven my career so far. How many of you heard about the Space Telescope, Hubble Space Telescope, or the New Horizons mission? Oh, excellent. Excellent. I'm seeing a lot of the little kids have heard about it too, and that's really great. Hubble was launched in 1990, so it's been flying for 26 years. We celebrated our 25th last year, and we've learned so much from that space telescope. We've learned more from that than from anything else. We have discovered billions of galaxies. Along with those are billions of stars and billions of planets to go with them. And we've really increased our knowledge of the universe and our own home planet with that. The second one is New Horizons, which flew by Pluto this past July. It was very exciting for us. There were 7 instruments on that spacecraft. 2 of them were the main ones that took the images that you've been seeing in the news as we went by the planet at a closest approach. One of those, named Ralph, was actually built by Ball Aerospace, and I was able to lead that to its completion. So it was very gratifying to see all those beautiful pictures. We originally, New Horizons usually start out just to kind of learn on something about Pluto, and hopefully to tell us something a little bit about Earth and the Moon, being that Pluto is about the same age as the solar system. It's out in the very dark recesses of our system, and to understand a little bit about the Pluto-Charon system so that it could tell us a little bit about Earth. Fortunately or unfortunately, depending on how you look at it, it's actually opened up more questions than we had before. We've learned quite a bit. Only about a quarter of the data has been downlinked, and we've already learned amazing amounts about Pluto and its 5 moons, which will in turn tell us a little bit more about the Earth. So some incredible experiences among some of the other things that I've gotten to do.
Okay. Sherry, same question?
Okay. Well, one of the nice things about being involved in STEM, science, technology, engineering, or math, is you can really have a career in different areas. And I started with the National Security Agency in Washington, so I had a little government work for a little while. Then I worked for IBM for a little while for some commercial and helped program their new chips. But by far, my most exciting part of my career was in the last 20, 25 years when I landed in the aerospace industry at Ball Aerospace. And the reason it's been so rewarding is that you get to be a part of things that really change people's lives and change your understanding of the universe. I worked on 4 different cameras for the Hubble Space Telescope. And one of the highlights for my career was, and I don't know if you were on that shuttle mission, but I got to see 2 shuttle launches of the Hubble Space Telescope, the new cameras. And just knowing that you had a part, I was a software programmer at the time, that I had a part in developing that camera that was going to go up in the shuttle and go put on the Hubble Space Telescope was just so incredibly rewarding. And then one of the cameras, the near-infrared camera called NICMOS, the team that I led actually wrote the software, and I was able to be in the control room when they turned on the camera. Talk about being nervous, because I thought, oh my gosh, what if the computer doesn't boot and my software doesn't work, and that camera's up there and now it doesn't work. But it did work, and just, again, being part of something that you knew was going to change our lives and bring on new discoveries. Aerospace has really been a wonderful place to have a career, and it all started with, I was at a National Science Foundation course in computers, and that's how I caught the bug, if you will, and stayed with it for my career.
Okay, Dr. Chao.
Well, thank you, Brian. And actually, I was not on any of the Hubble Space Telescope missions. Maybe too much gain?
Okay.
Okay. But I did participate in several of the development dives for the EVAs that went up to do the original repair flight, and so I do feel connected in a bit that way. If I had been on one of the repair missions, I'm sure that would have been one of the highlights of my career. I would have to say in my career, though, the 2 highlights were helping to build the International Space Station. I did fly on Mission 3A, which was the 2nd major assembly flight of the space station program. We went out over 4 spacewalks, and we went out and installed the Z1 truss and the 3rd pressurized mating adapter, going outside and bolting pieces onto the station, and then mating the electrical connectors to bring them to life, in addition to installing the main KU band antenna, which is the main data link, high data rate antenna link between the station and the ground. And then getting to go on a few years later and becoming the commander of the station and getting to run the whole operation up there was probably the highlight of my career. But, you know, space station, I want to talk a little bit about space station because, Brian, you want to know about the meaning of those two things that are significant to me. Space station is by far the most audacious engineering project we have ever done in space, by orders of magnitude. The only thing that even came close was Space Station Mir, the Russians put up in the mid-'80s, which was a lot smaller than ISS. But I think beyond the technical capabilities and accomplishments of the space station, both in the research and the actual engineering and construction, I mean, if you think about the construction over so many shuttle missions, so many autonomous dockings by Russian vehicles, the fact that we even got the vehicle, the first pieces together, the Node 1 and the FGB, the Russians work in metric, we work in English. There was no way to put the two pieces together before they launched. And the fact that everything fit together and worked is incredible. But I think the even bigger thing than the technical accomplishments of the station are the international relations that came out of it. Here we are working with former Cold War enemies, former Soviet Union, former World War II enemies, and we came together and we developed this framework, this partnership that developed this amazing piece of machinery that actually worked. And it's working so well, and it's a very visible civil space program. And what that means is that we are all aligned to make sure that that thing works. So in at least one area, all of these countries are aligned. What that means is that it spills over into other areas of the relationship. And people might say today, well, we shouldn't be working with the Russians. But my claim is, if we weren't working with them today, our relationship with them would be a lot worse. So I'd like to see that expanded in the future as we push the boundaries of exploration, as we go farther and deeper into space, one day to Mars. And who knows, one of you young people here tonight, you might be the first person on Mars. I always like to think about that. That's going to be awfully cool. And I hope I'm still around when we do get there. But to me, I think the overall bigger picture, in addition to the technical part, is why we do human spaceflight, why we do a space program. Thank you.
All right. And Colonel.
I am a fighter pilot that I had an opportunity to work on space programs. I worked for a visionary by the name of Dr. John Paul Stapp. Back in the early 50s, space was a goal that nobody ever thought we'd ever go into space. But the visionary, like Dr. Stapp, knew we were going to go there, and there were things that we needed to find out. I worked on the first zero-gravity program using T-33s because one of the questions was, could men or women put up with the extreme body stresses associated with prolonged zero gravity. And we started the first program in that. We went from there. Dr. Stapp knew there was going to have to be a small capsule when we go into space. So with the program, next program was Man High, where we went up on a 3-foot by 7-foot tall pressurized capsule, developing the life support system, the communications, the selection process, all of these things that NASA would be facing in the future. That was the Man High program. And what we learned from there was used by NASA when they went to the Mercury program. My next program was one on escape. We'd never put a man outside in a space environment. We had problems with how to escape, and we did the program that was called Excelsior. And I made 3 parachute jumps on that. And we developed a little 5-foot diameter drogue chute that we used for stabilization. That drogue chute is still being used today. In every ejection seat in the world, they have a small drogue chute that's used, that's deployed immediately after the seat leaves the aircraft. So what we developed back in 1960 is still being used today, which makes us all very proud of that. The next program that I was associated with was called Stargazer, and this was taking up a 12.5-inch Cassegrain telescope with a trained astronomer to look at the atmosphere, above the Earth's atmosphere, at various targets. I was so fortunate because I had an opportunity to work on all of these programs. All of them were dedicated toward space. All of them were dedicated toward finding out problems that we were going to have when we went into space. You know, NASA started in 1959, wasn't it? And we were doing research in the Air Force starting in 1955, seriously looking at the problems that we were going to have for the space program. So I was just very fortunate to be associated with that. Then I became a fighter pilot for the next 10 years. I retired, and then I got in the consulting business, and my latest fun thing was the Project Stratus, which was a parachute jump by Felix Bumgardner, 52 years after my jump, and he went, first man to go supersonic. He went 843 miles an hour from a jump from 127,000 feet. Once again, looking, and the objective of that was to flight test the next generation full pressure suit. You know, when they do the EVAs and they do the outside of the spacecraft, it's extremely bulky, it's very laborious, it's hard work, and one of the project objectives of Stratus was to look at the next generation full pressure suit, so there'd be more mobility, more flexibility in the suit to make it easier to work on EVAs. So I've been very fortunate in my life to be associated with these wonderful programs, and it's an honor for me to be on this stage tonight with these distinguished ladies and gentlemen that have contributed so much to our space program, and thank you for inviting me and let me be in with this very distinguished group. Thank you.
Thank you, Colonel. Okay, Sherry, we'll start with you this time, and then we'll follow up with the Colonel. Sherry, how have your missions or projects impacted or improved lives on Earth?
Well, as I mentioned, I work on the cameras for the Hubble Space Telescope, and one of the cameras, called STIS, was actually the precursor for our modern-day mammography. So a lot of the optical technology that was developed there is helping us today as women. A lot of the shuttle programs and the robotics that were done there are actually helping technology in artificial limbs. So they're helping humans, better fit people with artificial limbs. I looked a little bit more into Hubble, and some of the light-emitting diodes, LEDs, that we're familiar with was from the Space Shuttle program and growing plants on the Space Shuttle. That's how some of the LEDs were developed. So those are just a few examples of, some people think, well, why should we pay for space exploration, or why should our tax dollars go for that? Well, it's not just for space exploration. A lot of the inventions and technology that are used to further us in space come back to improve our lives on Earth.
All right, thank you. Colonel, I'm going to ask you the same question. How have your missions or projects that you've worked on over the years impacted or improved people's lives on Earth? Colonel?
The objective that we were really looking for was how to provide a means of escape from very high altitude. The Columbia was a horrible example of the dangers that every space flight encounters. They've done space flight so long now that we think it's just nothing to it. But every one is a tremendous experience with a lot of risk associated with it. And the one area that we have not been able to come up with a real good solution yet is escape on re-entry, because of the tremendous speeds and the heat and the problems associated with it. So that was our goal. It's still our goal. It's still a challenge to come up with a means of escape from very high altitude, and we'll continue working on it. There's people still working right today on that challenge, and I'm sure that we'll find a solution to that someday.
Great, thank you. Dr. Hardaway, I'll ask you the same question. How have your missions or projects impacted or improved people's lives on Earth?
Well, I was going to talk about the digital imaging for breast biopsy, but Sherry covered that very nicely. So I'll move on to something that all of you have used every single day of probably the last maybe 5 to 10 years, and that is Google Maps. So Earthwatch was the company that built the spacecraft originally. They've now been bought by Digital Globe. So there's several spacecraft orbiting Earth, taking pictures of everything on the land and in the ocean. And when you turn on Google Maps or some other maps on your cell phones, you're using that imagery. So we, as Sherry was saying, we don't just do space exploration, but we actually launch spacecraft and other space activities in in order to help lives down here on Earth. NASA's programs have increased many of our lives' productivities, everything from winglets to the edges of the wings on aircraft to the Velcro on your shoes have come out of the NASA programs. So not just about space exploration, certainly also about improving life here on Earth.
All right, and Dr. Chao, same question.
Yeah, following along the theme of doing things in space, making life better on Earth, on a personal level, beyond the space, excuse me, beyond the technological driver that NASA has been and the space program has been, and all the commonplace things that we take for granted here on Earth today. Personally, on one of my missions, my space station mission, we did a telemedicine experiment or demonstration using ultrasound. And it sounds like a simple thing to do, but actually it was pretty involved. And what we were able to do was to show that even novices like astronauts who are not medical doctors or sonographers, we could learn in just a matter of a few hours to recognize a good ultrasound image from a bad ultrasound image, and that we could be trained to use a standardized set of procedures and protocols to manipulate the probe on each other on the space station using voice commands from the doctors on the ground, watching us getting near real-time images back from the station. And so what we were able to do was show that we could be the hands, if you will, of the diagnostician, the doctor on the ground, and get diagnostic quality images of each other's internal organs, bones, teeth, and we even did the first ocular exam in space of an eye from the space station. So this has very practical implications for NASA, because as we venture farther and deeper into space, undoubtedly we'll have a medical doctor as part of the crew, but that person's not going to know everything, right? And so that person's going to need some guidance from the ground, some help, and we were able to demonstrate this telemedicine technique to help our own space missions in the future. But going back to making life better on Earth, the principal investigator of this experiment, who became a good friend of mine, he's actually chief of surgery up at Henry Ford Health System up in Detroit. He took this back down to the ground, found a technology company that was able to do this on a very small scale. When I say small, I mean compact scale, very rugged, so we could take this out in the field. And he sent teams of students, medical students, out in the field in developing countries through a United Nations program, doing wellness exams, for example, in Honduras, Madagascar, other places like that, on expecting mothers who live probably, at least 3 days by mule away from a hospital. And so they'd go do these wellness exams, and if a woman was having a difficulty with a pregnancy, they'd do an ultrasound exam, ship the images through the cell phone network or through a satellite phone network back to Detroit. They'd have an OB online talking to the doctor, medical students in the field, and they could very quickly make a judgment, well, no, this is not a big deal, you're okay, or, oh, maybe this could be something, you'd better start that 3-day journey now and get to a hospital. And so this was a real-world example of technology and techniques developed for space flight, making life better for people here on the ground. So that's my one small example.
All right, thank you. All right, this question is for Sherry and Lisa. You both worked on amazing missions, Hubble, New Horizons. In your opinion, how have your missions that you worked on changed humanity's views or understandings of the universe?
Well, I think we've had a lot of questions about where we came from, where Earth came from for millennia. And we've answered some of those questions, but we've also opened up new ones. I'll take Pluto, for example. We originally thought that Pluto was just a big rock of ice, basically out there somewhere, excuse me, in the distant solar system. And as we got up there, we realized that by looking at the images that we received, that there were very few craters. Now, the moon is very cratered. We'd expect that. There's no atmosphere. There's nothing to stop meteorites from hitting Earth. We thought there was nothing to stop meteorites from hitting Pluto, but there were very few craters, not enough to account for its age, 4.5 billion years. So what is going on? Well, we think that there's actually activity under the surface of Pluto, just like on Earth. So whether it's ice geysers or even a molten core, we don't know yet. We're waiting for more data to come down. But that is something that, I mean, we only discovered Pluto in 1930. So we haven't even known about it for very long. And in fact, 3 of its moons weren't discovered discovered till after we launched New Horizons in 2006. So that's how little we know about the system out there. And now we're finding all of these images that are very, very unexpected. So we're still trying to analyze that. So as man has looked through the heavens through the millennia, those questions are both being answered and asking new questions.
Well, many decades ago, Edwin Hubble, who the Hubble Space Telescope was named for, studied the Andromeda galaxy, and he discovered basically the first galaxy and hundreds of galaxies after that. If he were alive today, his telescope took a very famous picture called the Hubble Deep Field. It's a very, very small piece of our sky. In fact, if you held a dime about 75 feet away from you, that's how small of a space that the Hubble Deep Field picture was taken, but it represents billions and billions of galaxies. So just think, a couple decades ago we thought there were hundreds of galaxies, now we know there are billions and if not trillions or more. So our expanding view of the universe, the Hubble has helped us with that. And then another mission I worked briefly on was the Kepler Mission, another telescope that Ball Aerospace built, and its mission was to find exoplanets, planets outside our solar system. They've identified about 4,000 exoplanets, and 8 of those, they feel that the planets are actually very, very, very much like Earth. They have a sun, they're the same distance, about the same size. So now we're going off to say, okay, what other planets are out there that might have, as Lisa was pointing out, some other life or other means of sustaining life.
Okay, I might start a little controversy here, but Dr. Hardaway, a little follow-up question. I won't put you on the hook, but do you think that as we gain more information, this is just a question that we get at the Space Foundation a lot, do you think as we learn more information about Pluto, it might be reclassified as a planet, or is it's a dwarf planet?
All right, I'll give you my standard answer. If any of you think Pluto is a planet in your heart, keep it there.
All right. Fair enough, fair enough. Okay, this question is for Dr. Chao and Colonel Kinniger. How did the medical research learned from your missions and your current work help with understanding the hazards of space travel?
Well, part of what I do some work with the National Space Biomedical Research Institute in Houston, and the reason that the institute was created almost 20 years ago by NASA is specifically to address biomedical issues. And the fact is that people often have the mistaken misunderstanding that the technical barrier for us to go to Mars or something like that is something to do with propulsion or navigation or life support systems. I mean, sure, there's some challenges there, but really it has to do with how do we keep astronauts healthy during that kind of a voyage beyond the Earth's magnetosphere, during long duration periods of microgravity, followed by partial gravity, and then return back through that whole cycle. And so there are a lot of negative things that happen to the human body and other living systems when they're in space. Even when they're under the magnetosphere, we've discovered things with our space station missions that we didn't know before. You might have read in the press over the last few years that astronauts are coming back from the station of long duration flight with problems with their vision. Their vision is changing and not for the better. And so it's not very well understood. We have some theories, we have some ideas. We haven't found the smoking gun yet of what is causing that, but over 70% of long duration flyers to the space station have come back with some kind of vision problems, and I'm fortunate I'm not one of them. But so we have to solve these kinds of problems. No doubt as we fly longer and farther into space, we're going to find more issues that we didn't expect, especially when we go beyond the magnetosphere, when the crew is then exposed to the full brunt of the sun's radiation that usually gets trapped by those magnetic field lines. That's why life is possible here on Earth. I think we're going to find more and more things that we didn't expect, and so it's going to continue to be the biggest challenge. And the flip side of that is we were just talking about making life better on Earth. You know, there are things that we have studied, some of the negative effects like bone loss, other things like that, osteoporosis, which we've developed some countermeasures, some exercise countermeasures, as well as some pharmaceutical countermeasures that have helped to make life better here on Earth as well.
Okay, Colonel, same question. How has your, what's been learned from your missions or your current work help with the understanding of the hazards of space travel? Colonel?
We had a very extensive program on the Stratus project, as NASA's had on everything. They've had monitoring the physical responses to a space environment. We have spent an awful lot of effort on coming up with instrumentation that can allow people on the ground to interpret what's going on by virtue of the physiological monitoring systems that have been developed. There's a constant challenge to get better data and to get better approaches to problems that you encounter in a space environment. The point that Dr. made was when we go to Mars, there's a lot of problems that we're going to be facing that we have never faced before. And these problems have to be solved before we take a hazardous journey like that from our Earth to the planet Mars. The bottom line is that in the research programs that I was involved with, on every one of them, the physiological monitoring was an ongoing challenge that ended up coming up with better instrumentation that help us here on the planet Earth.
Excellent, excellent, thank you. All right, this will be open to all four of you. Again, you can answer in any order you wish. But can you share with the audience who has been an inspiration to you throughout your career? Teacher, mentor, colleague? Is there anyone that stands out that has been an inspiration, and why? We'll give them a second to think about that.
Well, let me start this off by saying there was a wonderful visionary by the name of Dr. John Paul Stapp. And by the way, there was a book just came out recently about his life called Sonic Wind. And I encourage anyone that's interested in the history of space flight to read this book, because it describes the genius, the visionary manner that this doctor had. He was a doctor of one of the first doctors that really looked at the physiological problems of putting man into space. So he was my sponsor, he was my visionary, he was a person that I had the highest regard for, and I think he was a great American that contributed significantly to our country.
Well, when I thought about that question, I listed a few people, but interestingly enough, only one of my mentors you would say is a classic, famous person. My advisor in Penn State was one of the original creators of the PDP computers, and she was very famous in computer architecture, and she was the only woman in the department at the time. So she was sort of the classic mentor who I was very grateful for. But then I had a whole list there that were people like my Girl Scout leader, or my first manager who encouraged me, or a colleague who always showed interest in my work. So I guess my encouragement to you in the audience is, if you are an educator or a Lego robotics teacher, or a coach or anything where you're touching young people's lives, you're making a difference, and you never know how much what you do is going to propel them forward.
I have to reiterate actually what Sherry said. I can't think of one person, but I can think of many. It started with my parents, of course. They completely encouraged me to follow whatever path I wanted to. They are not engineers. They had no idea what I do and don't understand all this space stuff. But I thought it was pretty cool, and they encouraged me to continue with that. And then there was kind of the handoff to my physics teacher in high school, and then there was my advisor, my freshman advisor in college, and my thesis advisor in graduate school, and several mentors as I've gone through my career. So there's kind of like this handoff as I kept going. It continues. My first job out of school, I worked on the space station. And so when I hear of somebody sitting right near me who has actually assembled it, it still gives me that encouragement to keep going and doing the things that I love to do.
Well, I've always been interested in airplanes and spacecraft and things like that. And so even as a young boy, I always looked up to the original astronauts and the Apollo astronauts. And all throughout growing up and through my education and then striving to become an astronaut myself, they were always serving to me as a source of inspiration. But once I got to NASA, actually before I got to NASA, when I got to NASA when I was invited to interview to be an astronaut, I got the great privilege to meet astronaut John Young, who's a friend of Joe Kinniger's here. And I was just so impressed with John at the time, and then after I got into NASA, spent a lot of time with John, getting to fly backseat in the T-38s with him when we were going cross country here and there. And he was just such a down-to-earth guy, just very approachable, very, very matter-of-fact. But as an operator, as a guy who knew how to fly spacecraft and operate aircraft, I don't think I never met anyone better. He's the only astronaut to have flown in Gemini, Apollo, walking on the moon, and flew the very first space shuttle mission as well. And so for us in the astronaut office, John was always kind of the astronaut's astronaut, and Joe and I were talking a little bit about him earlier tonight, and it was really neat to find out that they're good friends.
Okay, great. So talking to the community members here, especially the young students, give your thoughts about the importance of STEM education and why it should be important and supported in schools, and why young people should follow a STEM career. I'll leave that open to anyone.
Okay, I'll start. There are an enormous amount of different types of career paths that you can follow through STEM, whether science, technology, engineering, mathematics. You don't have to be a genius. I was just a regular kid. I mean, people kind of left me alone. I did my thing. I got my grades, and I went home, did my after-school activities. I wasn't a prodigy or anything, and you don't have to be. And I would encourage parents also to encourage their children, if they find one part of STEM that they're really interested in, encourage them to keep going with it, and they'll find their passion. There are so many different things that they can do with whatever interest that lies ahead.
Yeah, I would just ask your kids to follow their passion. Do they like to solve problems? Do they like math? Are they inspired by medical issues or science or astronomy? Find your passion. Absolutely find your passion, and then just start exploring what you can do with that passion. And as Lisa said, with STEM, the world is wide open in almost any industry or any, most companies have some application of STEM. But find your passion. Don't just be an engineer because your mom or dad was an engineer. Find what you like and then go dive into it.
Yeah, I absolutely agree with what's been said on this question. I think it's important to find your passion, because that's what you're going to do the best in, right? And so my wife and I, we have young kids, and what we are encouraging them to do, we're exposing them to as much as we can, and we can take a step back from STEM and include the arts as well, because STEM isn't for everyone, but I want them to know about it, and I don't want them to be afraid of it. And so I think it's important as young people to encourage your young people, your children, young people that you mentor, to kind of expose yourself to STEM, not be afraid of it because of the math, and it's something that through hard work you can get through it. I wasn't a natural at this stuff either. I had to work really hard to get the grades that I got, some of which I wish were better, but the point is that it's not a mystery. You can get through it, and if it's something you're really interested in, a particular area of science or engineering, don't be afraid of it. You really ought to go for it.
The members of the panel up here, we have one common denominator, and that is when we were young people, we established goals to work toward. And we found out that in order to achieve success, it takes hard work. STEM is the way to our future. All of us up here on this stage, all we're trying to do is promote that STEM as an objective for our young people to set, because we need this for the future of our society, the future of the world. So I encourage all of you that have any interest at all in science, technology, engineering, to put put yourself to it and work hard, and remember that it's a success takes hard work and dedication, but you set a goal and you work toward that goal and you never get deviated from it. So I encourage everyone here, if you have any interest at all in science, please get involved in the STEM program. Please work hard, because our country and our nation, our world is going to depend upon the people out here in this audience. And all we want to do is encourage you to do the best you can to join these great scientists that are here to my right. I'm just a fighter pilot, I'm not a scientist, but I know what it takes to be successful in the engineering field, and we encourage you to please apply yourself to that goal. Thank you.
Excellent. So to sum that up, the students in the audience, when they get a very difficult homework assignment from their teacher, should not complain anymore. Is that correct? That's what you're saying? Okay. So want to make that clear. Can the four of you talk about the importance of space exploration to this community? Why? We've all touched on it a little bit, but is there anything else you would like to share to get them to understand, realize why space exploration is so important? Is there anything you want to add?
Well, we've talked about the technical spin-offs, the advantages, the practical advantages that space exploration has brought to people here on the Earth. But I think it's more important that the intangible things are actually more important. I remember during Apollo, I remember during the first shuttle launches, even when we were building the first elements of station, you know, everybody was really proud of that. I think we as a nation, we felt really good about ourselves, especially being the first nation to land people on the moon, the only nation so far to land people on the moon. And it really inspired the next generation. These are things that are difficult to measure, but I think it made everyone want to reach a little higher. You know, not just scientists, not just engineers, but you know, artists, musicians, people who write books and poetry and literature. I think everybody was inspired to try a little bit harder, and that's what's important. I think that's what comes out of a human exploration program and a non-human exploration program too. The New Horizons mission, I mean, how exciting the things that we've discovered about Pluto. I mean, it's just amazing the things that we're still finding out. In recent weeks, we've discovered another planet in our solar system. How is it that we haven't found that in all these years? It's really, really mind-boggling, and I think space is something that everybody can get excited about, and I think the common denominator is that it gets us excited as human beings and as Americans, and important to excite our young people.
So one of the reasons that I got into the space, besides it being very cool, is that eventually Earth won't be able to sustain the human race. Eventually we're going to have to leave Earth, or we're going to have to find other planets to settle on. But space is hard. It is hard building spacecraft to do what you want them to do, and to take 9 years to get to Pluto and still work when it gets there. And so we do things very small and baby steps. And so we won't be off Earth, I don't believe, in my lifetime, maybe not even the lifetime of some of the little young ones here, but eventually it will have to happen. And so if we start now, if we do all of the exploration that we're doing now and keep going, eventually we'll have another place to go.
Okay. Anyone else? Okay. What is one thing, and I'm going to make all of you answer this one. What is the one thing that you are most excited about regarding the future of space exploration? It can be manned, robotic. What do you see as the most exciting thing about the future?
Well, I'll go because I just told you mine, and that's finding other planets. We do have a mission called Kepler that's looking at just our very small portion of the Milky Way galaxy to look for other planets. And to date, we have seen over almost 5,000 other planets just in our little part of the universe. About 1,000 of those have been confirmed by alternate sources, so we know they are definitely out there. And we suspect at this point maybe about 12 of them could be inhabitable as another Earth. So we are getting there, and we are finding other places for us to live and work eventually, and I find that extremely exciting.
I would say for me, it's the prospect of going to Mars. You know, I grew up during the Apollo era and the moon, but thinking about going that next step and sending man that far away to another planet that we really don't know that much about is just really exciting to me to think about. And it might be somebody, as we talked about, might be one of the youngsters in the audience that puts that first foot on Mars, and just think of how exciting that would be.
You know, we went to the moon because we were in competition with the Soviet Union. The fact is, we were in a Cold War, and this was, in those days, we were on a war footing. And we had to beat the Soviets, we had to show that we were superior, and that's why we did it so quickly and we did it so well. Fact is, if there had been no Cold War, maybe we would have gotten to the moon anyway, but it wouldn't have been nearly as quickly, and there would not have been the urgency. So today, we're not in that kind of a footing, and it's, I want to see us go to Mars. I want to see us send people to Mars, but there's not that urgency. There's not that drive to do it and drive to do it quickly. So that's a little bit disappointing. I mean, we are moving forward with human spaceflight and exploration going farther out, but the fact is, on the schedule today, the first flight of astronauts on the next vehicle, the Orion, that's designed to go beyond low Earth orbit, is not scheduled to happen until 2023. So I don't know when we're going to get to Mars if we follow the traditional model. So the exciting thing for me is that, you know, we've seen some commercial activity that NASA is helping to fund and assist technically to companies like SpaceX and Boeing to develop their own capabilities to commercially take astronauts to and from the ISS. And the exciting thing, the extension of that was more exciting, is Elon Musk, who's the founder and CEO of SpaceX, has publicly stated many times, most recently about 2 weeks ago, that he intends to go and colonize Mars, and he wants to live and die on Mars. Now that's exciting because that sets up the opportunity for a collaborative exploration between commercial and government, and that could accelerate us in the absence of a Cold War, which I'm not saying would be good for us. That will help us to accelerate the timetable that we might be able to get astronauts farther and deeper into space. There's some other ideas that I can't talk about right now, or we don't have enough time to talk about, that will leverage off of that kind of a collaboration that can open up a lot of doors to a lot of neat exploration. So that's what excites me about the future, is the possibility of this commercial government collaboration that also extends exploration.
You know, what's so exciting, we're living in a very exciting period of time. The knowledge that we've gained in the last 20 years, the knowledge is exponential in the way that we're learning more and more about space and about the planets and the whole galaxy. And what we know now today is so much more than we did know 20 years ago. So we're in an exciting period of time, and man is going to be part of that. I had the opportunity not too long ago to be with John Glenn. And John Glenn said, you know, explorers have a common denominator, and that is they're curious. Curiosity is a great benefit that we have as humans. And the early explorers that developed the world as it's known today are still here in this audience and in the future to be inquisitive and to be an explorer. And John Glenn nailed it right on the head. All explorers are inquisitive.
All right. So all of you have mentioned a little bit about going to Mars. Dr. Hardaway mentioned we're going to have to get off this planet eventually. So I know a lot of discussion right now is about, should we go to the moon first before we go to Mars? Should we go straight to Mars? This is kind of a personal question for me. What are your thoughts about your background knowledge? Do you think we should go straight to Mars? You know, that's the big thing in entertainment right now after The Martian just coming out. You know, we need to get to Mars. But should we go to the moon first and test the systems? I know they're very different systems between the moon and Mars. Any thoughts?
Yeah, I'll start because I have strong opinions on this. I want to see us get to Mars, but I definitely think we should go to the moon first. And there are many reasons for that. There are There are practical and technical reasons for going to the moon first. For those who say, well, we went there in the 60s and the early 70s, that's true, but we haven't gone there since then. And so there's a lot to be learned about going back to the moon. We have to relearn how to land people on another planetary body. It's a perfect place to test everything on a practical level. You want to habitats, your environmental control and life support systems. You want to test your rovers, your suits, your operations concepts, and you want to train your crew. I mean, you don't necessarily want your first crew to land on Mars to be rookies, right? So you want to train them maybe in reduced gravity surface operations in essentially a vacuum. So why do you want to do that on the moon? Well, it's the closest planetary body we have. It's 3 days away. If you have a problem with something, you can get the crew back pretty quickly. Once you do that trans-Mars injection burn, even when the planets are aligned, you're talking about at least 6-month transit times one way, and you're not going to get the crew back for a year. So there are a lot of practical reasons to do it. On a political level, which basically drives all decisions, frankly, there are a lot of political reasons to go to the moon. Other countries are interested in going to the moon. China has made, it's an open secret, China intends to land astronauts on the moon. The moon is so important to China and Asia culturally, there's no way they're not going to try to do it. Most recently, Russia and Europe have talked about partnering to go to the moon. We are currently, the United States, we're leading the International Space Station program. We are the leaders. Russia is the other major partner, but we're the leaders. And we have this whole coalition, Russia, European Space Agency, Japanese Space Agency, Canadian Space Agency. We ought to expand that to include countries like China, and we ought to lead the effort to go back to the moon. Otherwise, they're going to go without us. And when are we going to go to Mars? I'm not sure. You know, we might go retrieve a boulder from an asteroid and do some stuff in cislunar space. But there's frankly no real plan to go to Mars, and the way to go to Mars, I think, is in a stepping stone fashion, and that's to go to the moon first, leading this international coalition.
Yeah, I'll have to say I agree with Dr. Chao that we should go to the moon first, only because in my field, which is mission assurance, most of the time we're dealing with failures in the aerospace business. And unfortunately, we don't learn our lessons very well. And it's been a long time since we've been to the moon. And we have a lot of new technologies. And I really think we should get some successes under our belt and go there first. It takes a whole village to do things. That's my saying, it takes a village to build a spacecraft or an instrument. It's going to take a whole country to band together and get our technology together to even go to the moon, and I think we ought to do that and then springboard from there.
Covered very well.
Yeah, I have to say I'm in the moon camp as well. We've learned a lot in the last almost 50 years since we landed on the moon. There are so many new technologies that we can take advantage of and try them out on the moon before we get to Mars. I'd love to see us go to Mars. I'd love to see it in my lifetime. But again, since we don't really have a good plan right now, and the moon is definitely within grasp, I'd love to see us do that first.
All right. Excellent. Okay, before we open up questions to the audience, are there any last thoughts from the panelists? Anything you'd like to share with the audience tonight regarding the importance of STEM or space exploration, or anything that we haven't covered that you would like to share to hopefully inspire some of these young people here tonight?
I didn't understand the question.
No final words?
Yeah, I'll throw out my favorite question to all the younger folks in the audience. When you're looking for a career and you're in STEM and you're in the Erie Academy, which I just found out about it, think hard about what problem do you want to solve? What problem do you want to solve in the next couple years in your life? Not what job do you want to have or what hours do you want to work or something like that. What problem do you want to solve? And then look and say, okay, what does it take for me to get into that field to solve those type of problems? Am I really excited about solving a medical issue because somebody in my family might have a medical problem? But just think about what problems do I want to solve going forward.
And I would add that if you come up with something that you want to solve and you decide that's not for you, you can change. There's no reason you have to stay in one path. My career has not been a straight line. It's had lots of twists and turns and sometimes 360 circles in it. And you can always change. You can always use the knowledge that you've gained in school to follow something else.
Anyone else? No? Okay. All right. So we're going to open up the questions to the audience. If you have a question, please stand up and shout it out, and I will try to repeat it. Okay. So the question is, for Dr. Chao, what did it feel like being in space?
Going on a spacewalk. Going on a spacewalk is probably the most surreal thing I've ever done in my life, especially the first one. You know, you've been trained a lot. We spent basically 10 hours to every 1 hour that we actually did the spacewalk training underwater in the water tank. And so I was very familiar with the tasks, the procedures, the process, everything I had to do. I could do it in my sleep. But nothing prepares you for that moment when you get to go to open the hatch for the very first time, and you open it up and you kind of venture out into open space for the very first time. The flight surgeon told me later that my heart rate at that moment spiked to about 135, you know, from about 60 or so, spiked to 135, and then it came back down, and as we got to work and got everything done, it was fine. And then 2 days later, we went out on our second EVA, and he said the thing that he marveled about was that my heart rate didn't change at all the moment I opened the hatch and we went back outside. But that very first time, it's weird. It's weird. You get out there and you look down at the Earth, and of course we've seen the Earth through the windows of the shuttle, and it's fantastic. It's marvelous. But when you look at that Earth outside with a visor, your helmet, you've got peripheral vision. For the first time, the Earth felt like a ball to me, and it was pretty weird.
Okay. Having trouble seeing. Yes.
What kind of activity do you think is on Pluto?
What kind of activity do you think is on Pluto?
Well, we're not completely sure, but because there aren't as many craters as we expected, we think there might be some plate tectonics, which means kind of like when we have an earthquake and the plates underground are moving together. So we think there might be something like that. We also know that there's water as well as methane on Pluto, and in fact there's so much water that a lot of the mountains are made of ice, water ice. So we think maybe under the ground the water was liquid and it's actually moving around and moving the crust of the planet, just like here on Earth.
Yes, sir. In the gray. You catch that? I didn't catch that. Say it again.
How does the spaceship go through the Earth's atmosphere?
How does the spaceship go through or rip through the Earth's atmosphere?
I don't know the exact figures, but I know it's a lot of TNT underneath that shuttle that blows those astronauts up. And I actually had dinner one time with a crew for the repair mission, and they were so excited to sit on that TNT and get blown up into space. I couldn't believe it. But maybe you could tell us what that feels like, because I've always wanted to know what that would feel like when the bomb goes off.
Well, you're right. The space shuttle, the space shuttle, of course, had 2 solid rocket boosters on the side. And so what we would do is 6.5 seconds before launch, the 3 shuttle main engines would start, and they're running on liquid hydrogen, liquid oxygen, and it's very smooth. And you kind of hear the rumble, and you feel it, and they start up. And then at T0, the command is sent to light the 2 solid rocket boosters. Once that command is sent, you are adding almost 5 million pounds of thrust to the stack. And so you feel like you are exploded off the pad. There's a big loud boom, The explosive bolts all fire, and the vehicle leaps off the pad. In fact, by the time it's cleared the tower, which is only about 130 feet or so tall, the vehicle, that big heavy vehicle with all that fuel, has already accelerated to over 100 miles an hour. And so you hear the wind resistance, you hear the wind noise. You know, when you're accelerating in a vehicle, you can hear the pitch of the wind change. That is changing so quickly on a shuttle. It's pretty amazing. And you're kind of pushed back in your seat, not a lot of G's, but some G's, and the sky quickly turns from, you know, daylight to darkness, because you get up there pretty quick. By the time the solid rocket boosters burn out, you're only a little over 2 minutes into the flight and an altitude of about 180,000 feet. So things happen very quickly.
And I'll add that when we have astronauts aboard, we actually have to try to temper it so that it's not too much for the humans. New Horizons, even though it took 9.5 years to get there, it's the fastest moving man-made object ever. It was on the biggest rocket that we make as humans, with extra strap-on boosters to it. And we talked about taking 3 days to get to the moon. And the New Horizons spacecraft passed the moon in 6 hours. So that thing is moving fast.
Okay, in the green there.
Do you think NASA's going to go beyond this galaxy?
Do you think NASA is ever going to go beyond our galaxy?
I don't know. I might defer to our Ball Aerospace folks, because the first man-made object that has a chance of going beyond the galaxy, I can guarantee is not going to have a human on board. The galaxy is very big. Solar system is very big. I mean, we only now got New Horizons past Pluto, and as you heard, even at a record speed, it took 9 years to get there. So the Voyager spacecraft that we launched in the 70s, they only recently made it to what we call the heliopause, which is when the spacecraft reaches beyond the influence of our sun. And so even that is a far cry from beyond the Milky Way galaxy. I don't know what it would take to get beyond the Milky Way galaxy, but we'd have to definitely invent warp drive for that to happen.
All right, that's a homework project for all of you students in here.
I was going to say, we don't have the technology today, but that's the problem that you guys need to solve.
Exactly. Yes?
Is it easy to see the Earth from outer space?
Is it easy to see the Earth from outer space? Actually, Colonel, you could probably answer this as well and get a different perspective from both you and Dr. Chao.
Well, the Earth looks very beautiful where we're standing. It's beautiful from above, but it's very hostile. He's outside of a spacecraft, and he's floating around in a vacuum. It's beautiful. It's spectacular, but it's extremely hazardous. His life is completely dependent upon the fabric that's surrounding his body and giving him atmosphere. So the Earth looks beautiful from above, but you have to remember how hostile the environment is. And as you look up, I never went higher than 100,000 feet, but as you go up and you get to that altitude, 100,000 feet, and you look at the horizon, it looks pretty much the same. But as your eyes go up, just about 20, 30 degrees, suddenly it's black. And everyone that their first trip into space, the first thing they're really amazed about is how black the sky is above. It's really a different world completely. But the Earth is beautiful from above, but it's even more beautiful when you're sitting right here where we are.
Well, Joe is absolutely right. And yeah, the Earth is very beautiful, but if you look at where the space station is, if you take a globe, a globe about this big, and the space station is orbiting at an altitude of about, say, 250 nautical miles, 280 miles. So you measure that off and you put it up there. It's only about 1/4 of an inch or a little more. So we're kind of skimming the surface of the globe, of the planet, even on the space station. So we can't see the entire planet looking out the windows of the space station. You can see a good part of it. You can see the curvature of the Earth, but you're only seeing a piece of it. Now, the astronauts that went to the moon, of course, they were going almost 250,000 miles away, so they could definitely see the entire Earth. But I think what's really going to be weird is the crew that goes to Mars or somewhere close to Mars, watching that Earth get smaller and smaller and smaller and then turn into a star. That's going to be weird.
Okay, right there, young lady in the gray, yes.
What else do you think could be found on Pluto except ice?
What else? Okay, the question is, what else could be on Pluto besides ice?
Well, we're still looking at the data, but we know there's methane, which is a gas. We know that there's some rocks. We don't know what kind, and some of that we won't be able to tell until we actually land there. So it's going to be another 10 months or so before we get all the data, and keep your eyes on the news because they'll definitely publish all of that.
Okay. Sir, way in the back in the blue there.
Sure, this question's for Colonel Chao. So, what was your experience stepping out of the capsule knowing that you weren't going back in?
Okay, the question is, Colonel, what was the feelings of your experience stepping out of that gondola and knowing that you weren't going to be able to get back in? What were your thoughts and feelings?
I've never heard that question before. You know, when it came time for me to jump, I was highly trained. All of us that have been in that environment have been trained over and over and over again, and you mentally go through it 1,000 times. So when I was standing on the step of that capsule at 103,000 feet and get ready to jump into an area that nobody had ever done before, but I had complete confidence in myself, and it really takes three things to accomplish a mission like this. You have to have confidence in your team, you have to have confidence in your equipment, and you have to have confidence in yourself. Those are the three ingredients that everyone has to have. So when I got ready to jump, I was ready to go. I knew there was a group of people, my teammates were on the ground waiting for me to get there. And as a matter of fact, jumping from that space was the quickest way to get down to Earth.
Well put, well put. Let's see, I'm having a hard time seeing. Young lady in the back there in the pink. So if I think I heard this right, how long do you think it will take, and I'm guessing this might be a Kepler question, how long do you think it will take to find another planet like Earth?
Well, right now, as I mentioned, there's about 4,000 planets that are outside our solar system. And the way they determined that is they looked at things which were stars which were like our sun, and when they saw things go across the sun, they determined that it was a planet orbiting the sun. And of those 4,000, they've determined that about 8 of them are very, very, very close to what we have on Earth. And I know what the scientists are doing now is they're using things like the Hubble Space Telescope. They're going to use the new James Webb Space Telescope soon to take pictures of those 8 planets so they can find more and more about, is there any sign of water or life or anything on those planets. So I think we've narrowed down a field and we have some good candidates, and now we're going to have to use our other telescopes to explore them.
So just to put things into perspective, these exoplanets that we're discovering that may be like Earth, how long would it take to get there? How far away are they? Would it be possible to travel there with technology, current technology?
Actually, I think probably not at this point. They're too far. They're light years away. A light year being that it would take you a year if you were traveling at the speed of light to get there. And some of them are hundreds and thousands. So we don't have the technology at this point, certainly to get humans there, and even our probes and spacecraft. So there's a problem for all of you out there to solve.
Very good. Okay, yeah. Not sure how we're doing on time. How are we doing on time, Principal? Okay, a few more questions. Great. Yes, sir, right back there.
Say that you did find living stuff like us on another planet. What would you do? Would you send people there to find them? Or what?
Okay, the question is, if we did find something, an intelligent being on another planet, what would we do about that? Just so you know, I'm sorry?
Next question.
Yeah, next question. Just so you know, we have the smartest people on the planet working on that problem, and I don't think they have an answer either, so.
Well, my hope is that we would leave them alone, but study them.
There you go. All right. Yes, ma'am.
My question is for Dr. Leroy Chao. If anyone broke a bone, well, has anyone ever broke a bone in space? And if they did break a bone, what would they do to heal it?
Okay, the question is, has anyone ever broken a bone in space? And if so, or if they did, how would they heal it? I know this is a very big problem for space travel.
Well, the fact is that we have had pretty significant medical events in all phases of flight. Ascent, orbit, descent, entry, landing, all that. We've had pretty significant medical events. Nobody has broken a bone yet in space, but we've been trained how to deal with it in the case that it does happen. So we do get extensive training, basically kind of paramedic training on how to stabilize a patient, how to administer first steps, first aid, things like that, and then get on the radio down to Houston to a doctor and who can advise us on further steps. In the very worst case, from the space station, we can all get into our vehicle, our Soyuz spacecraft, and come back down to Earth. But fortunately, we haven't had to do that. But we are trained, and we do think about contingencies like that. It's certainly not out of the realm of possibility. Somebody could break a bone, but fortunately, it hasn't happened yet.
All right, this is going to have to be the last question. Actually, we'll do two more. I think we have time for two more. Way in the back in the gray.
So how far is the closest star after the sun, and how long would it take to pass this?
So how close is the closest star to our solar system, and how long would it take to get there? Are you talking walking or in a car? Okay.
It's an Alpha Centauri?
Yeah, it's Alpha.
Yeah, you guys are asking hard questions.
Collaborate.
I know, we have to collaborate here. We're all agreeing that it's Alpha Centauri is the closest star, but it's certainly thousands of light years.
It's millions. I think it's 4.3 million light years away, if my memory serves me correct. So, and light years, remember, that's the speed of light, which is 186,000 miles a second. So,
do you have a smartphone? Just Google it. All right, I think we had, there was a gentleman back here somewhere that had a question, had their hand up. Yes, sir, right there in the blue stripe. Yes.
Do you have any books that you would recommend these young children to read that have inspired, a favorite book of yours that you would recommend?
Okay, the question is, does the panel recommend any books for anyone out here to read to inspire them? Have any of you written a book? One of your books?
I'm trying to think of books that would be the correct level. Many of our astronauts have actually written books about their experiences. Gene Cernan, one of the Apollo astronauts, has a book out. And there are several others. And I always find them inspiring. I can't speak to the level that they're written at. So maybe parents can take a look at them and see if their children can understand them.
I can suggest a movie. The Last Man on the Moon is coming to the Boulder International Film Festival, and Gene Cernan, who was the last man who walked on the moon, will be there. So if you can, I don't know exactly when the timing is, but they just released the schedule. So it's called The Last Man on the Moon, and I have seen it, and it's very good. It's about what the astronauts go through mentally, emotionally, physically to land on the moon.
Gentlemen, any? Nope. Okay. All right. Unfortunately, I think we are out of time. Thank you, everyone, for coming. I think this has been a great evening. Enjoy the rest of your evening and safe travels.